Hey there, Math Hoppers! In this video lesson, we will tackle the dreaded trigonometric identities. So in addition to remembering your reciprocal identities, where tangent is sine over cosine and cosecant is 1 over sine, there's a really important set of Pythagorean identities. You'll need to do these. So let's review how we come up with it. Remember when we learned the unit circle? We built a triangle within the unit circle. The horizontal length was x, the vertical length was y, and then that radius, because right here was the origin of the unit circle, the radius was the hypotenuse. And since it was a unit circle, the radius was 1. Remember, there was a circle surrounding this triangle. So we knew from the Pythagorean theorem that x squared plus y squared equals r squared. And then once we learned the unit circle and we learned that r was equal to 1, we could say that x squared plus y squared now equals 1. And then we learned that all of those points along the unit circle, those xy coordinates, were actually cosine and sine values, where cosine was our x coordinate and sine is our y coordinate. So once we learn that, we can put this together and make what's called a Pythagorean trig identity. And that is cosine squared plus sine squared equals 1. And that is a really important identity, and we're going to manipulate it in a few ways to get some other identities. So let's see what we can create from this main Pythagorean identity. We're going to get from cosine squared plus sine squared equals 1, we're going to create this. So if we subtract sine squared from both sides, we get cosine squared is equal to 1 minus sine squared. So that's just manipulating this main identity, but it's important because if you're working with an identity you need to simplify and you see 1 minus sine squared, you now know you can replace that with cosine squared. Okay, let's go back to cosine squared plus sine squared equals 1, and let's divide every term by cosine squared and see what we get. Cosine squared divided by itself is 1. Remember that sine over cosine is tangent, so sine squared divided by cosine squared is tangent squared. And 1 over cosine, well, that is secant. So 1 over cosine squared is secant squared. So this gives us another Pythagorean identity where secant squared is equal to 1 plus tangent squared, or vice versa. If you see 1 plus tangent squared in a problem, you can replace it with secant squared. Okay, now let's take this identity and let's manipulate it a little bit. If we take this 1 plus tangent squared equals secant squared, and we subtract tangent squared from both sides, we will see that secant squared minus tangent squared is equal to the number 1. So this is going to be really handy. If you ever see secant squared minus tangent squared in a problem, replacing it with 1 is going to make it considerably easier. All right, let's go back to the main identity. Cosine squared plus sine squared equals 1. And this time I want to divide every term by sine squared. So since cosine over sine is cotangent, cosine squared over sine squared is cotangent squared. Sine squared over itself is 1, and 1 over sine is cosecant, so 1 over sine squared is cosecant squared. And that gives us another identity. Now, just like we did with this identity, let's use this new identity and subtract cotangent squared from both sides. If we subtract cotangent squared from both sides, we see that cosecant squared minus cotangent squared is equal to 1. And so those are some really important Pythagorean identities that will help you simplify these trig identities, these trig proofs, whatever you want to call them. Knowing these is going to help you. But if you don't memorize all of them, at least know that cosine squared plus sine squared, or sine squared plus cosine squared, is equal to 1 because it produces all of these other relationships. All right, so when you're doing these, this is what is going to happen. You are going to use the fundamental trigonometric identities and the reciprocal identities to write expressions in simplest form. That's all we're really doing here. And we're going to do that by knowing the trigonometric identities and key algebra skills. All of that's going to be very important. So here are some things to keep in mind when you're solving these problems. You are going to want to factor when possible. Factoring is never going to go away. It's never going to, once you learned it in Algebra 1, it kind of comes back literally forever. You want to look for Pythagorean identities. The identities we just learned will come in very, very handy. You want to rewrite everything in terms of sine and cosine whenever possible. You want to distribute when possible. You also want to remember your reciprocal identities. And I'm going to say this. Tangent is going to be rewritten as sine over cosine, cotangent as cosine over sine. Don't really think of those as 1 over tangent, 1 over cotangent anymore. And you're going to need common denominators when adding fractions. There'll be lots of times where you're going to have fractions that you're adding, and they have trig expressions in the numerator and denominator, and we will have to add them. So remember, there's not one set of steps that we can tell you, do this step 1, do this step 2, to solve these. So looking for relationships is really, really crucial. Let's just jump in because the only way to learn these is to practice. So if we want to simplify 1 plus tangent squared over cosecant squared, let's look at what we have. Let's rewrite the problem. First thing I said was look for those Pythagorean identities. So 1 plus tangent squared should kind of jump out at us. It's something we just learned. 1 plus tangent squared is equal to secant squared. If you don't remember how we got it, remember if we took that main identity, cosine squared plus sine squared equaled 1, and we divide everything by cosine squared, we got 1 plus tangent squared equals secant squared. So since that's a Pythagorean identity, I definitely want to replace 1 plus tangent squared with secant squared, and then I'll see if I can rewrite in terms of sine and cosine. So rewriting, I get secant squared over cosecant squared. And this I really like because I know that secant is the reciprocal of cosine and cosecant is the reciprocal of sine. So I can work with that. I can definitely take that expression and rewrite it in terms of sine and cosine. And when I do that, I know you're thinking, well, it might get a little bit ugly because what is secant? Secant is 1 over cosine, so secant squared is 1 over cosine squared. So I'm going to replace my numerator with a fraction, but it's really going to be okay. And cosecant squared, that's going to be 1 over sine squared. So when I rewrite this, I'm going to get a new fraction with a fraction in the numerator and a fraction in the denominator. And that happens a lot with these problems. And that's okay because we know how to divide fractions. We know that we keep the numerator and we multiply by the reciprocal of the denominator. And when we do that, it looks like this. 1 over cosine squared times the reciprocal of 1 over sine squared, which is just sine squared over 1. And this is actually quite nice. 1 times sine squared is just sine squared. Cosine squared times 1 is just cosine squared. So we wind up with sine squared over cosine squared. And that should look really familiar because we know tangent is sine over cosine. Therefore, sine squared over cosine squared is tangent squared. And that's going to come up a lot. Remember that because tangent is sine over cosine, sine squared over cosine squared is simply tangent squared. All right, let's do another one. In the numerator, we have 1 plus tangent, and in the denominator, 1 plus cotangent. And yes, it's 1 plus tangent of theta, 1 over 1 plus cotangent of theta. I'm kind of terrible at saying my thetas or my x's with these. So what are we going to do? We see a fraction and a denominator, both of which have a tangent and a cotangent, or one of which has a tangent and the other has its reciprocal. So I think we're going to rewrite tangent and cotangent in terms of sine and cosine. And you may be hesitant to do that because what's that going to do? That's going to make 1 plus a fraction over 1 plus a fraction. That actually happens quite often with these problems. So we're going to go ahead and do that, even though it means we'll be adding fractions in the numerator and denominator. Rewriting 1 plus tangent theta gives us 1 plus sine of theta over cosine theta. And rewriting 1 plus cotangent of theta is 1 plus cosine over sine. So now we have this numerator with an expression where we are adding a fraction and a whole number. We have a denominator with an expression where we're adding a fraction and a whole number. So what we're going to do is simplify both the numerator and denominator. And yeah, that means by adding them. So what we're going to do is we're going to take 1 and we're going to change it to have a like denominator. So we're going to make what I call a glorified version of 1. We see that we need a denominator of cosine, so we're going to rewrite 1 as cosine over cosine. Here we see we need a denominator of sine, so we'll rewrite 1 as sine over sine. No big deal. That 1 will become cosine over cosine, that 1 will become sine over sine, and we will have two fractions to add in the numerator and 2 fractions to add in the denominator. Now, it might look bad, but let's look at the silver lining. At least both fractions have like denominators, and I can add them now. So let's go ahead and do that. In the numerator, cosine plus sine is just cosine plus sine. It's like adding x plus y. It's just x plus y. So cosine plus sine is cosine plus sine all over cosine, the like denominator. And here, sine plus cosine is just sine plus cosine all over the like denominator sine. So we're going to get cosine plus sine over cosine divided by sine plus cosine over sine. Again, we have a fraction with a fraction in the numerator and a fraction in the denominator. And that's okay. We know how to multiply, or rather divide fractions. We're going to keep the fraction in the numerator, and we're going to multiply by the reciprocal of the fraction in the denominator. So when we do that, we get cosine plus sine over cosine times the reciprocal of what was down there. So sine over sine plus cosine. Now we can just multiply. And first, before we multiply, I want to simplify. We should know that cosine plus sine can divide into sine plus cosine. Remember, addition is commutative. This is the same. Sine plus cosine is the same as cosine plus sine. So we'll divide those out, and we are simply left with 1 times sine over cosine times 1. And when we do that, we get sine over cosine. Yet again, we remember that tangent is sine over cosine, and so we know that our answer is tangent. That's it. We took this big, huge, ugly expression and turned out it was just equal to tangent. All right, let's do one more. We have tangent of theta over cosecant squared of theta plus tangent of theta over secant squared of theta. And again, whenever we're presented with fractions in these trigonometric expressions, we will need to add them. But first, we're going to rewrite them in terms of sine and cosine. We have tangent, we know we can rewrite that. We have cosecant, we know that's the reciprocal of sine. We have secant, we know that's the reciprocal of cosine. We know that we can rewrite every single term here in terms of sine and cosine, so that's our first step. Our numerators are now sine over cosine, and yes, we're pretty used to having a fraction in each part of our fraction now, right? A fraction in the numerator, a fraction in the denominator. So our numerator is sine over cosine, and our denominator is 1 over sine squared. Remember, cosecant and sine are reciprocals, so cosecant squared is just 1 over sine squared. And we're going to add that to, again, we have a tangent in the numerator, so the numerator is sine over cosine divided by 1 over cosine squared, because secant and cosine are reciprocals, so secant squared is 1 over cosine squared. All right, this might look horrible, but we had to do it, and it's not going to be that bad, because what we're going to do now is for each set of fractions, we're going to simplify them. And how? Well, we know how to divide fractions. We're going to keep the numerator and multiply by the reciprocal of the denominator, and then we'll get to adding these fractions eventually. So we're going to take sine over cosine divided by 1 over sine squared, and we are going to keep sine over cosine and multiply by sine squared over 1. And then we're going to add it. We're going to add it to this fraction, right? We're going to clean that up. We're going to say we're going to add that to sine over cosine times cosine squared over 1. So we just rewrote these. We haven't actually done any math yet. But this is going to help us, because what's going to happen here is we're going to just multiply. We're going to turn this into one fraction just by multiplying. We're going to turn this into one fraction by, again, multiplying. And then we will simply have two fractions to add. So sine times sine squared is sine cubed all over cosine. So we're going to get that. Sine times cosine squared is just sine times cosine squared all over cosine. So we simplify and we get sine cubed over cosine. Remember, sine times sine squared is sine cubed. And then sine times cosine squared is simply sine times cosine squared all over cosine. Now, the good news here is we already have like denominators. We can add these fractions straight away. So when we add those, we simply say this is sine cubed plus sine times cosine squared all over our like denominator of cosine. Not too bad. We're definitely not done. Remember, we're simplifying these. You can't leave your answer if it looks worse than what you started with. Okay, so what are we going to do? I want you to look for relationships. And remember factoring. Factoring is never going to go away. Notice we have a sine cubed, so we have a sine term here and a sine here. So both of these terms in the numerator have a sine that you can divide out. So we are going to do just that. We're going to factor out sine of theta from both of those terms. So we're just going to rewrite the numerator in factored form. When we do that, we are going to get sine cubed divided by sine and sine cosine squared divided by sine. That's what's going to be left in the parentheses. So we factored out a sine. Sine cubed divided by sine is sine squared. Sine times cosine squared divided by sine is cosine squared all over cosine. Now, what's in parentheses should look like it stands out to you. It should look like it has a different value because sine squared plus cosine squared is equal to 1. Therefore, this is just going to be sine times 1. I can essentially cross that out. Sine times 1 is just sine. So we have sine times 1 in the numerator, all over cosine. So once again, we have sine over cosine. Sine over cosine by now, for sure, we know, is tangent. So this entire expression, tangent of theta over cosecant squared of theta plus tangent of theta over secant squared of theta is simply equal to the tangent of theta. Those are trig identities and simplifying them. They really just take practice. Remember the rules, remember your identities, and these will get better. If you have questions, you know what to do. Subscribe to our YouTube channel, send those questions to me, and I'll make you a video. Till next time, Math Hoppers, take it easy.